So we will speed up the solution, and I hope you bear with me. So we have the scenario 1, 3 known shapes and 1 unknown. So make sure the left side of the reference line is the negative side and the right side of the reference line is the positive side. So we will first, for the first shape is the cone head or the bullet, as you have the bullet shape. So we have the density of 600 kilogram per millimeter squared, and of course we have to get its density and of course its dimension, and we will solve for its relative mass. So you can see from the solution right here, we got its center of gravity, and the mass is 1.05 pi times 10 raised to 4 negative 4 kilogram. So the centroid from reference is negative 185.75 millimeter. Next, we will solve for the cylindrical, the hollow ones, the body. So you can see we have the outer distance is 10 millimeter and the inner distance is 4 millimeter. Its length is of course 170 millimeter. Take note that since it's lying from left side of the reference line, it's negative. So we are solving for the mass calculation. So we have the mass of 1.428 pi times 10 raised to negative 3 kilograms. So as you can see there, my solution, it's the centroid, x over 2. But take note, it lies on the left side of the reference line. Next is we have the solid cylindrical. That's the stick one. Of course, its dimension is 4 millimeter and its length is 170 millimeter. We have to solve for the volume once again. And of course, we have the mass of 2.04 pi times 10 raised to negative 4 kilograms. The centroid is negative 85 mm. Same as before. Yes, and now we will solve for the unknown, the solid cylindrical. Take note, the L is small letter L, and the dimension is of course same, 4 mm. We will solve for the mass, and of course our mass has a known variable, and we are getting its centroid from reference, and this is the positive centroid because it lies on the right side of the reference line. Now let's proceed with the Varignon's theorem. Its goal, centroid must not lie to left of A dash A, because that's what it's given in the problem. So we have the total of the moment, it's equals to 0, and now let's input all our mass calculations from earlier, and of course it's centroid. So we got that solution, and of course I'm going to be waiting for that. We got 0 is equals to negative 0.49. I'm not going to keep up with that. So you can see the solution right there. So make sure you get the setup and coordinate system, you get the properties of the component, and of course after that is the calculation of mass, and there we go. We got its length, but x is equals to 170 plus the small letter L, and the final answer is 683.523 millimeter.